Hi, we present our paper Bold, a natural language interface for dashboard authoring. I'm Vidya Setlur, and this is work done with Arjun Srinivasan at Tableau Research. Now, I think we can all agree that dashboards are one of the most commonly used artifacts to interact with data. But that being said, dashboard authoring remains a fairly complex and underexplored topic, especially from a visualization research perspective. Pandey et al. Presented a set of dashboard objectives that describe the various themes or goals for authoring dashboards and were implemented in a system called Medley. We apply this framework as a basis in our work. While specific examples of how we support these dashboard objectives will be provided a bit later in this talk, please refer to Pandey et al.'s paper for more details on the actual objectives. While evaluating Medley, multiple participants mentioned that manually specifying attributes and intents is often tedious and hinted towards the use of natural language input. This need motivates our work to extend existing natural language interfaces for visualizations to explore how we could support dashboard authoring. Here are some examples of how natural language can be used to author dashboards, where an initial view showing monthly sales by segments can be updated to create an interactive dashboard based on the input utterance, display an overview of company performance over time. In this work, we are specifically interested in two goals: exploring the idea of using natural language input for dashboard authoring and formulating a list of design goals for supporting such dashboard authoring in an interface. We implement Bolt, a natural language interface for dashboard authoring. Bolt's interface comprises of a data panel on the left and the main canvas in the center. Typing a natural language utterance in the text box at the top of the canvas and pressing the Enter key invokes the system interpretation of the utterance. The parser uses a combination of grammar and lexicon-based approaches to infer dashboard objectives. The recommendation panel shows previews of system recommendations, and a dashboard author can add content from the recommendation panel to the canvas. Once items are on the canvas, authors can refine the dashboard by dragging, resizing, or removing objects, and also export the dashboard as an interactive web page. Bolt is implemented as a web application that accepts any tabular CSV dataset as input, and visualizations in the tool are created using Vega Lite. Now let's see a demo of Bolt in action. Bolt parses natural language input utterances to infer dashboard objectives and data attributes, and uses this information to recommend dashboards that authors may be interested in. Now let's consider the utterance summarize changes in regional sales in the context of a sales dataset. Bolt detects that the author is interested in the sales and region attributes and that the author wants to create a dashboard to help understand data changes over time. Based on this interpretation, Bolt generates a dashboard that includes relevant views as well as an interactive widget that enables comparing yearly changes. Let's now look at a movies dataset and consider a different utterance, top grossing movie analysis, that is phrased like a dashboard title. Here, Bolt sees the token top and infers that the author is interested in showing items with the highest values for the gross attribute. The system then generates a dashboard with a set of sorted bar charts and an interactive widget to set the number of displayed items. Bolt can also generate dashboards in response to more specific questions, such as which gender wins the gold for USA, asked in the context of an Olympics dataset. Bolt infers that the author is interested in comparing values for gender based on the number of gold medals and generates a dashboard based on that interpretation. Besides automatically configuring a dashboard layout and using consistent colors across views to facilitate comparison, Bolt also pre-populates the country filter widget to USA since it was mentioned in the input question. Bolt also gives authors the option to assess and correct its response for ambiguous utterances. For example, consider an utterance, company performance overview, that does not indicate the attributes the author is interested in. In this case, Bolt runs a series of statistical functions on the underlying data to predict that the author might be interested in the sales attribute and provides an option to update the attribute using a drop-down menu. Authors can add an entire collection to the canvas or choose elements across recommendations to compose a custom dashboard. Bolt currently supports 5 dashboard objectives derived from Pandey et al.'s dashboard intent framework as described earlier. Here are examples of Bolt's responses for utterances in the context of different datasets, including sales, movies, and Olympics medal winners. Utterances in examples A, B, and C convey both attributes and objectives, whereas the utterance in example D only references attributes and does not clearly state the dashboard objective. Here, in example A, we see dashboards corresponding to the change summary objective that contains a set of views and widgets that highlight changes in a measure's value over time across other attributes in a dataset. Here, the dashboard displays the year-over-year change in the measure sales. Example B shows the top-end dashboard objective displaying top data categories for a specific measure. Here, the dashboard displays top categories for the gross measure. Example C shows a dimension comparison objective with a set of views and widgets that facilitates comparison between values for a categorical attribute. Here, the dashboard compares the values for the dimension gender. Example D shows the measure comparison objective that presents a set of views that enables the comparison between two measures to understand their relationship and underlying data trends. Here, the example shows a dashboard comparing the measures discount and profit. Using Bolt as a design probe, we conducted a preliminary user evaluation with two main goals: to elicit feedback on the idea of natural language-based dashboard authoring, and to assess Bolt's current design and identify areas for improvement. We conducted the study with 6 participants having varying levels of experience with dashboard authoring: 3 novices, 1 intermediate, and 2 experts. Sessions were conducted remotely and lasted approximately 30 minutes. To avoid biasing participants and to understand how they might naturally interact with the natural language interface, we only gave a brief introduction to the tool and asked participants to use natural language to author dashboards in the context of 3 datasets, discussing their reactions to system responses. After the trial phase, we demonstrated any unexplored system capabilities using additional utterances and concluded with the semi-structured interview focusing on the 2 study goals. Participants issued a total of 14 utterances, 2 to 3 per session, with 10 utterances being phrased as dashboard titles or keyword style queries, 3 questions, and 1 command. Among the 12 interpreted utterances, measure comparison was the most frequently referenced objective, followed by change summary, measure overview, and top N. Participants were unanimously positive about the idea of using natural language for dashboard authoring for bootstrapping users new to a dataset or to a visualization tool, and to support rapid ideation and prototyping as the key use case. Participants noted that they would benefit from example utterances to help understand the system capabilities. Participants also noted that they see Bolt's recommendations as a starting point and want the ability to specify or fine-tune individual views, such as adjusting encodings, swapping axis orientation, etc. While we intentionally did not support manual view specification in Bolt to specifically focus feedback on natural language input, integrating the current experience with the manual view specification environment would enable more multimodal utility of the interface. Finally, we employed a heuristics and template-based logic for natural language interpretation and dashboard recommendation, exploring machine and deep learning-based techniques to further generalize natural language interpretation would be an interesting direction to consider. With that, here's the QR code to the paper and our contact details. Thanks for listening.